All right, let's talk about chemistry a little bit. We'll do a couple of videos on that. Talk about energy and matter, go through the atoms, and then we'll spend some time on chemical bonds and chemical reactions. And we'll finish this first section up with the inorganic compounds. And in the second part, we would like to do a little work on the organic compounds. What is matter? Matter is everything that occupies space and has weight. Matters come in states, 3 different states. They can be solid, liquids, or gases. The easiest to understand on that is water. In the below 0 Celsius environment, the water is solid as a ice. And then between 0 and 100 degrees Celsius, the water is liquid. And then afterwards it becomes steam, and that's its gaseous state. Energy, on the other hand, has no mass, nor does it have weight. It is measured by the effect it has on matter. Energy is the ability to do work and to put matter into motion. Kinetic energy is energy that is performing a work right now, like it's moving an object, or the water is coming down the river or the waterfall. Potential energy is energy that's inactive, that is stored, but that can be easily used and transformed into kinetic energy. In the water situation, we can have it be a dam that's holding the water back, and we let it go when we want to make some energy. In our body, that can be fat reserves. We have multiple different energies in the body. We have chemical energy, and that's energy that's stored in a substance molecular bond. And when we break that bond, we set that energy free, and that makes us do some work. For example, a muscle contraction. We have electrical energy, and that's when charged molecules move through the body real fast. And in our body, those are ions that do that electrical energy. The nerve impulse is a good example of that. Then we have mechanical energy, and that's energy that's mechanically used. So that's a muscle, for example, contracting, and that's the mechanical energy. And then we have light energy, such as visible light, that's energy, but we also have X-rays, for example, that we cannot see. We can convert energy very easily, but what we lose in the process is heat. You leave a light bulb on a long time, it actually gets nice and warm around the light bulb, especially the older ones. The newer ones we try to not have that much heat get lost, because we basically have to feed the electricity into it and it's lost as heat. But when we convert energy, we always lose heat. Atoms are, the term atom means incapable of dividing. We know now that that's not always quite true, but when we created the concept of atoms, that was certainly the case for us and our understanding. But all matter that we see and that we live in is made up of a limited number of different substances. These substances are called elements. And one particle of one of those elements is an atom. And an atom is structured with a center and energy orbits that surround the center. Kind of like the planet Earth and the moon, or the sun and the solar system. Is probably a better comparison. So in the center we have 2 types of particles. We have protons And the protons are positive charged particles. And then we have neutrons, and they have no charge. They are neutral. And then in the surrounding orbits, surrounding that nucleus, we have electrons. And electrons have a negative charge, the same charge as the proton has in the positive. So they equal each other out. The electrons don't really have any mass, but they are just a buzzing charge around that nucleus. When atoms combine chemically, they form molecules. When that happens, we have chemical reactions that take place because we need to combine or dissociate atoms from one another. These chemical bonds are going to be very important, these forms between atoms and atoms, and we're going to spend some time on that. So the bonds, the connection from atom to atom, is what is created when these atoms react with one another. We have the electrons surrounding a nucleus that's in the center of an atom, and what actually interacts from atom to atoms are those electrons. And the electrons of the outermost orbit, the orbits come like the solar system, with some very close to the sun or to the nucleus and some further apart and further away. And the outermost orbit is called the valence. And the atoms of the valence, the electrons of the valence, interact with another atom's electrons of that valence. And that creates a chemical bond. So the valence, the outermost shell of this atom's electrons, really determines what goes on and the behavior of an atom. Simplistically speaking, it's not completely true, but we have a rule that's known as the octet rule. And that's the rule of 8. And what that means is that an atom's outermost shell, for the most part, can have a maximum of 8 electrons. And if it has not 8 electrons, if it contains less than 8, it is reactive. If it has the 8 electrons, it's an atom that is not interested in reacting with another atom, and we call that an inert element. So it is non-reactive. We got a few there. We got helium there, and see that's where the octet rule is broken because the innermost shell has not as many electrons. But then here we got neon, and that's another example where there is 8 in the outermost shell. When we look at chemical bonds, we have 2 main types that we're looking at today, and then we have a third smaller one. We have ionic bonds. And ionic bonds create ions. And in those bonds, electrons are transferred from one atom to another atom, creating charged atoms. So this is where we either give an electron up or we take an electron in. And depending on if we have one extra electron or not, we're going to be charged to negative if we have one extra electron, or positive if we don't. So these are our salts, like our table salt, for example. Sodium chloride, that is. So if sodium chloride in a dry form is a salt combination, if we put that in water, it dissociates, those atoms dissociate, and they become charged atoms that float around in water. Then the other type of bond we have are covalent bonds. And in covalent bonds, we share the electron between the atoms. And what that does, it makes those atoms more stable as a unit. Because if they're not having a full set of 8 electrons in the outer shell, they're not quite stable. But if they share those outer electrons with another atom and make basically 8 out of them, 8 in both atoms, that becomes very stable. And we can have 1 electron that's shared, or 2 electrons that's shared, or even 3 electrons. And we call those then single bonds or double or triple bonds.